Welcome today to the session where we're going to look at question 5 of the 2018 September KwaZulu-Natal paper 2, and the question focus on trigonometry. Now you get a bit of reading time in the exams, so we're going to do a reading exercise as well today, and we will look at how the question is asked, what type of clues they give us, and how that compares with the marks as well. Okay, so let's look at question 5.1. So they've given us 4 tan alpha plus 5 is equal to 0, and alpha is between 0 and 180 degrees. Evaluate without the use of a calculator. Square root of 41 cos alpha minus 4 sin of minus 150 degrees cos of 180 degrees. So something we'll need to do, we need to convert that into tan of alpha is equal to something, and that something will probably be negative because of that plus, and we will then draw a diagram on the Cartesian plane and look to where it will lie, and given the tan is negative and the alpha is between 0 and 180, we will think it will be in the second quadrant. And now let's look at the next part where they say evaluate square root of 41 cos of alpha. Now something tells me that r that we're going to calculate up here will be square root of 41 or related to it, because this is quite a random square root of 41. Then 4 sin of minus 150, so we need to know how to work with negative angles. And then cos of 180, I'll draw a quick cos graph for that. Then in question 5. Before I forget, 5 marks, all of that for 5 marks, that's quite a bit of work. If we compare it with question 5.2.1, cos of 33, sin of 33 as our denominators in this fraction. So my guess is we will somehow use compound angles or double angles in this question. Then we're going to go to cos. This looks like a nice complicated one. Cos of 140 minus sin of 90 minus theta, sin of 130 plus cos of theta. Okay, now just noting the causes are opposite. I don't know if that will be useful. We see the 90 minus, so we think of complementary angles. And we look at cos of 140, which means it's 180 minus 40. But if you look at this 130, it's the same as 90 plus 4. So maybe we can do something with that. And then cos of a negative angle, which should be quite easy to do. So 6 marks and 5 marks. I think in terms of the work required, it will be a bit less than in 5.1 for similar marks. Then prove the identity. 2 sine squared x over 2 tan x minus sine of 2x is cos x over sin x. So looking at that, we will see the double angle and know that sine of 2x is 2 sine x cos x, and we will use the identity of tan x is sin x over cos x, and we might use the identities sine squared plus cos squared is equal to 1 to convert that into 1 minus cos squared. Okay, so no real issues at this stage. And then looking at the final question 5.4, which is worth 7 marks. Now I think this is probably the question where you'll get your 7 marks the easiest if you know your stuff, because I see sin theta cos theta, which makes me think of sin of 2 theta. The square root of 3 could be that it's related to one of the special triangles. Okay, so we've read through this, talked a little bit, and now let's get stuck into the questions. One reason it's important to read through is that our subconscious will start to process the information while we're doing the others, which when we get to our questions in the end, we will probably have a good idea already to do. Okay, so first of all, I'm going to draw my diagram, and it will be in the second quadrant because of the positive that goes over and the information that they've given us. So for tan alpha plus 5 is equal to 0, so that gives us 4 tan alpha equal to minus 5. Tan of alpha is equal to minus 5 over 4. Okay, we know tan is y over x. And the first two quadrants y is positive, so this means we can write this as 5 over minus 4. So x is minus 4 and our y is 5. Now we can work out the radius, the arm, and we can say r squared is equal to minus 4 squared plus 5 squared, just Pythagoras, which is 16 plus 25, and that's going to be 41. So our r squared is 41. So that means our r is just the square root of 41. Now, as you can see, it brings us back to this number that we identified earlier. Okay, so now we've got all the preparation done to do the sum. So square root of 41 cos of alpha minus 4 sine of minus 150 degrees cos of 180 degrees. Okay, so for the cos of 180 degrees, I'm going to draw a quick cos graph. So it goes from 1 to minus 1, and that will be a 0 at 90 degrees, and at 180 degrees, minus 1. So now we can start to simplify this. Okay, square root of 41. Now we know cos of alpha is x over r. So x is minus 4 over r, which is the square root of 41. Minus 4 sine of, okay, now I'm going to change that to a negative sign of a negative number, so it will be minus 4 of negative sine of 150 degrees. Okay, now cos of 180 degrees is just minus 1. Now something we could have done is to add 360 degrees, and if you add those together, that would be 210 degrees. So you would have gotten sine of 210, which is 180 plus 30 degrees. Okay, but I'm just going to use this method for today. So let's simplify square root of 41, square root of 41. They can cancel, which leaves us with minus 4. Minus and a minus and a minus will give us a minus sine of, okay, so 150 degrees is the same as 180 degrees minus 30 degrees. So we have minus 4 sine of that. This is minus 4 minus 4 sine of 30 degrees. Okay, it's a positive sign because it lies in the second quadrant. And minus 4 times. Now, if you know your special triangle, sin of 30 is equal to a half, which is minus 4 minus half of 4, which is 2, and that gives us minus 6. Okay, so this is worth 5 marks. And as you can see, we've had to do quite a bit of work. It's the diagram, finding the r, finding cos of -1, rewriting the equation, And so I would say this is quite a complicated question to start off with, but if you can do it, then you're well off. Let's start with question 5.2. Okay, so we have simplify without the use of a calculator, cos of 99 over cos of 33 minus sin of 99 over sin of 33. Okay, so what we'll do is to start off by saying, okay, let's get a lowest common multiple as our denominator. Okay, I like to, it could have been cos 33 sin 33. I like to write sin 33 first. One reason is if we look at our compound angles, so sine of alpha plus beta, that's equal to sine alpha cos beta plus sine beta cos alpha. So I like to write it first, and then that will become sine of 33 degrees cos of 99 degrees minus sine of 99 degrees cos of 33 degrees. Okay, so if we look at the denominator, that reminds me of the double angles. The sine of 2 theta is 2 sine theta cos of theta. So we're going to change it to make it look like that. But what we do with the denominator, we also have to do with the numerator. And remember the brackets. Okay, so, and the next thing I'm going to see is that that looks like the compound angle with a minus sin of alpha, and it will be minus beta in this case. But that would give us a minus 66. So if I swap it around by taking out the negative, it becomes sine of 99 degrees cos of 32 degrees minus sin of 33 degrees cos of 99 degrees. Okay, all over, that would be sine of 2 times 33 degrees, or sine of 66. Okay, so now we can use that and say minus 2, and it will be sine of 99 degrees minus 33 degrees, all over sine of 66 degrees. Okay, so already we're starting to think 99 minus 33 is 66. So that will leave us minus 2 sine of 66 degrees over sine of 66 degrees. So we can say we can cancel. Sine of 66 goes into itself once and into sine of 66 once, which leaves us with minus 2. Okay, so we needed to recognize the double angle and the compound angle for sin. Okay. Let's move on to 5.2. So cos of 140, sine 90. Okay. Now, I'm going to convert this to a 90 plus 40. So it will be sine of 90 degrees plus 40 degrees plus cos of theta, not alpha. Okay. Now, the reason I'll change this one is in the second quadrant where this lies, the 130 and the 140, sin is positive. So this one, we don't want to mess too much. So cos of 140 we can write as cos of 180 degrees minus our 40 degrees. Minus, and then sine of 90 minus theta is the same as cos of theta. Okay, now we're starting to see cos of theta. We will see sin of 90 plus will give us a cos of 40 degrees plus cos of theta, and that will become Now, because that's in the second quadrant, cos is negative, so it will be a negative cos of 40 degrees minus cos of theta. And we can take out a negative, which leaves us with cos of 40 degrees plus cos of theta over cos of 40 degrees plus cos of theta. So I'm just going to put it in brackets so it looks the same. And we can cancel factors, so we can cancel the whole bracket, which leaves us with minus 1. Okay, so we could have done that one with saying, okay, that's cos of 140, which is the same as cos of 90 degrees plus 50 degrees. And we could have said sin of 130 degrees is sin of 180 degrees minus 50 degrees. And we would have gotten the same result. With that one, you just need to be careful because you're changing the cos and you have to worry about the sin. Let's move to our last two questions or last page. Okay. Identities. So obviously when we do identities, we start off with left hand side is equal to and right hand side is equal to. I don't think we'll do a lot on the right hand side. So let's start with the left hand side. So 2 sine squared x over 2 tan x minus sine of 2x. I'm going to leave this, or change this 2 sine squared x to 2 times 1 minus cos squared x over. Okay. The reason why I do that is I see in the numerator there's only a cos x, so no sins or anything. So I'm going to remove that or change it so that somehow there will be a cos x. And 2 tan x will be 2 times sine x over cos x minus, and sine of 2x is 2 sine x cos x. Now, these double angles are on your formula sheet, but it's much quicker to remember them. And if you do a lot of examples, you don't have to learn them. It will just come naturally. It's only when you get stuck that you can refer to your information sheet. Okay, so if we look at the denominator, we've got a cos x in the fraction in the denominator. So I want to cancel that out. So I'm going to multiply by cos x. But obviously we have to multiply by 1 not to change anything. So it's cos x over cos x. And that will become 2 cos x times L 1 minus cos squared x over. And the cos x will cancel that. So it's going to be 2 sine x minus 2 sine x, and cos x times cos x is cos squared x. So we're starting to see cos x in the numerator, sine x is a common factor, so we're getting closer. So that will leave us with 2 cos x 1 minus cos squared x, and we take out 2 sine x as a common factor, 1 minus cos squared x, and we can cancel the factors of 1 minus cos squared x. We can cancel the factors of 2, which leaves us with cos x over sin x, and that's equal to the right hand side. Okay. We could have done it slightly differently as well, where we leave the sin squared and then we change this 1 minus cos squared to a sin squared. That will work as well. So any method, as long as you get to cos x over sin x. Okay. Now let's look at this last question. The 7 marks, which I think is the easiest 7 marks on this in this specific question. Okay, again, sin theta, cos theta, so double angles. So that will be, I can rewrite that as 2 sine theta cos theta. And to get 2 from 8, we will have to divide by 4. So it's minus 2 square root of 3 over 4. Okay, so now we're going to say 2 sine theta cos theta is sine of 2 theta. And that simplifies to minus square root of 3 over 2. So that should remind you of the special triangle, which is 60 degrees. So, and because of the negative, it will be lying in the third and fourth quadrants. So third and fourth quadrants. Okay. So we'll get our reference angle, which will be 60 degrees. We can use the calculator as well, ignoring the negative. So we can start off with saying 2 theta is equal to, because of this third quadrant, 180 degrees plus 60 degrees plus 360 degrees times k, or k times 360 degrees, or 2 theta is equal to 360 degrees, so we're in the fourth quadrant now, minus 60 degrees, so that will be the minus 60 degrees plus 360 degrees times k. Now let's simplify that and somehow get theta is equal to. So 2 theta is equal to 240 degrees plus 360 degrees times k. And 2 theta is equal to 300 degrees plus 360 degrees times k. So the 2 theta is that, so 1 theta will be all divided by 2, 120 degrees plus 180 degrees times k. See how the 360 changes, and theta will be 150 degrees plus 180 degrees times k. So that's all we can do, but there's something missing and we should never forget it. K is an element of integers, and that's all done. So this should give you a good indication of double angles and where they pop up and how to recognize them. So just to finish off, if you see a sine theta cos theta, you will think sine. If you see things like sine squared minus cos squared or cos squared minus sin squared, you will think of cos of double angles. Thank you.